What is the solar system moving through right now? Have you ever felt like you're standing still? Like the ground beneath your feet is solid and motionless, a fixed point in an unchanging world. It's one of the most convincing illusions in all of human experience. We wake up each morning, we walk through our days, we go to sleep at night, and throughout it all, we feel absolutely nothing. No motion, no speed, no sense that we're hurtling through the cosmos at unimaginable velocities. But here's the truth that will shatter that illusion forever. Right now, at this very moment, while you're reading these words or listening to this voice, you are moving, not just moving. You are racing through the universe at speed that make the fastest jet aircraft look like a crawling insect. Your planet is spinning. Your solar system is orbiting. Your galaxy is hurtling through intergalactic space, and the entire universe is expanding around you. This is not poetry. This is not philosophy. This is physics. And the question I want to explore tonight is one of the most profound, humbling, and mind-expanding questions you could ever ask. What is the solar system moving through right now? Where are we going? What's out there? And how do we even know? Let me take you on a journey. A journey through the invisible currents of the cosmos. A journey through the space between the stars. A journey to understand where we are, where we're going, and what we're passing through. This is not just astronomy. This is the story of our place in the universe. The illusion of stillness. Close your eyes for a moment. Imagine you're standing on the surface of the earth. The air is still. The ground is solid. Nothing is moving. You feel perfectly stationary. It's a beautiful illusion. But that's all it is, an illusion, because even at this very moment, you are spinning. The Earth rotates on its axis once every 24 hours. At the equator, you're moving eastward at about 1,670 kilometers per hour. That's faster than the speed of sound. You're moving faster than most commercial jets, and you don't feel a thing. But that's just the beginning. The Earth isn't just spinning, it's also orbiting the sun. Our planet travels around our star at an average speed of about 107,000 kilometers per hour. That's about 30 kilometers every second. Fast enough to cross the entire Earth in less than a minute. Fast enough to travel from New York to London in about 4 seconds. Fast enough to make your head spin if you really think about it. And yet, you feel nothing. But that's still not the end of the story. The sun isn't stationary either. Our star is part of a galaxy, and that galaxy is moving. The Milky Way is rotating. The sun orbits the center of our galaxy at about 828,000 kilometers per hour. That's about 230 kilometers every second. Every second you live, you travel 230 kilometers through the galaxy. Every heartbeat carries you further into the cosmos. And even that isn't the whole picture. The Milky Way itself is moving. Our entire galaxy is traveling through intergalactic space at about 2.1 million kilometers per hour. That's roughly 600 kilometers every second. In the time it takes you to blink, you've traveled more than 100 kilometers through the universe. Now, it's important to understand something here. These speeds are measured in different reference frames. The Earth's rotation is measured relative to the Earth's axis. The Earth's orbit is measured relative to the sun. The sun's orbit is measured relative to the galactic center. The galaxy's motion is measured relative to the cosmic microwave background. You can't simply add them together to get a single speed. Each motion exists in a different context. Each one is relative to something else. That's the fundamental insight of Einstein's relativity. There's no absolute frame of reference. There's no universal speedometer. Every speed is relative to something. But the lesson remains the same. We are moving. We are moving through multiple layers of motion, and we feel absolutely nothing. But there's a deeper question. What are we actually moving through? Not the speed, not the direction, the medium, the stuff, the environment. What is the solar system moving through right now? What fills the space between the stars? What is the cosmic ocean in which we swim? Let's find out. The interstellar medium, the cosmic ocean. The space between stars is not empty. It's not a perfect vacuum. It's not nothing. It's filled with something scientists call the interstellar medium. It's a diffuse mixture of gas, dust, and cosmic rays that fills the vast spaces between the stars. But diffuse is an understatement. The interstellar medium is incredibly sparse. On average, the space between stars contains about 1 atom per cubic centimeter. That's about 10,000 times less dense than the best vacuums we can create on Earth. It's emptier than anything you can possibly imagine. But it's not empty. The interstellar medium is made up of several components. First, there's gas, mostly hydrogen and helium. About 90% hydrogen and about 10% helium by number of atoms. There are trace amounts of other elements: carbon, oxygen, nitrogen, and a tiny bit of everything else. Then there's dust, tiny solid particles, microscopic grains of silicate, carbon, and ice. These dust grains are smaller than a grain of sand. They are smaller than a human hair. They are like smoke particles drifting through space. And then there are cosmic rays. These are high-energy particles, protons, electrons, and atomic nuclei, accelerated to nearly the speed of light. They come from supernova, from black holes, from the most violent events in the universe. They are constantly streaming through the solar system and through your body. The interstellar medium is not uniform. It has different phases. There are hot, tenuous regions where the gas is heated to millions of degrees by supernova explosions. There are warm, neutral regions where hydrogen atoms are cool and relaxed. There are cold, dense regions where molecular clouds form and stars are born. And there are clouds of ionized gas, where ultraviolet radiation from massive stars strips electrons from atoms. The interstellar medium is the raw material of the universe. It's the stuff from which stars are born. It's the stuff from which planets form. It's the stuff from which life emerges. It's the cosmic ecosystem in which we live. Think about that for a moment. Every star you see in the night sky was born from the interstellar medium. Every planet you can imagine formed from it. Every atom in your body was once part of it. We are the interstellar medium. Recycled, we are the universe, looking back at itself. It's one of the most beautiful and humbling truths in all of science. The local interstellar cloud, our cosmic neighborhood. Now let's zoom in. Let's look at the immediate neighborhood of our solar system. We're not just floating in empty space. We're moving through a specific structure, a structure called the local interstellar cloud, sometimes called the local flood. The local interstellar cloud is exactly what it sounds like. It's a cloud of interstellar gas and dust. It's about 30 light years across. It's warm, it's tenuous, and we're moving through it right now. The cloud is about 6,500 degrees Celsius. That's hotter than the surface of the sun. But don't worry about burning up. The cloud is so sparse that we barely notice it. The atoms are so spread out that they don't transfer heat effectively. It's like standing in a hot oven. The air is hot, but it's so thin that you don't feel the heat. The local interstellar cloud has been moving around the galaxy for billions of years. It's part of a larger network of clouds. These clouds are the remnants of supernova explosion. They are the debris of ancient stars. They are the material from which new stars will be born. We entered the local interstellar cloud about 50,000 years ago, and we'll leave it in about 20,000 years. For humans, that's an eternity. For the universe, it's a blink. Inside the cloud, the density is higher than the average interstellar medium, about 0.1 to 1 atom per cubic centimeter. That's still incredibly sparse, but it's enough to create a measurable pressure. It's enough to affect the solar wind. It's enough to shape the heliosphere. But let's think about what this means. We are currently inside a cloud of gas that is moving through the galaxy. The cloud is like a river, and we're drifting through it. It's not a static environment. It's dynamic. It's flowing, and we're along for the ride. When the solar system passes through a dense part of the cloud, the heliosphere shrinks. More interstellar material reaches the Earth. More cosmic rays penetrate our atmosphere. This might have affected the Earth's climate. It might have affected the evolution of life. There's evidence that the Earth has passed through dense molecular clouds in the past. Some scientists believe that these encounters might have triggered ice ages. Others believe they might have influenced the evolution of species. The interstellar medium is not just a passive backdrop. It's an active force in the history of our planet. The heliosphere, our cosmic bubble. The heliosphere is a bubble of space dominated by the sun. It's the region of space where the solar wind dominates the interstellar medium. The solar wind is a stream of charged particles flowing outward from the sun. It's a constant breeze of protons, electrons, and other particles traveling at hundreds of kilometers per second. It creates a protective bubble around the solar system, a shield against the interstellar medium. But the heliosphere is not a perfect bubble. It's shaped by the interstellar medium. The solar wind pushes against the interstellar medium, and the interstellar medium pushes back. The boundary between the two is called the heliopause. It's where the solar wind stops and the interstellar medium begins. The heliosphere is asymmetric. The solar wind pushes outward, but the interstellar medium is flowing past us. We're moving through the local interstellar cloud. The cloud is creating a bow shock, a region where the interstellar medium piles up against the heliosphere. The bow shock is about 100 astronomical units from the sun. That's about 100 times the distance from the Earth to the sun. It's beyond the orbit of Pluto. It's the frontier of the solar system. Inside the heliosphere, the solar wind dominates. Outside the heliosphere, the interstellar medium dominates. We live inside a bubble blown by the sun. A bubble that protects us from the interstellar medium, a bubble that allows life to exist on Earth. The heliosphere is not just a curiosity. It's essential for life. It deflects interstellar radiation. It shields us from cosmic rays. It protects us from the harsh environment of the galaxy. Without the heliosphere, life on Earth might not exist. The solar wind is the sun's shield, and we're living inside it. The Voyager 1 and 2 spacecraft have crossed the heliopause. They've left the heliosphere. They are now in interstellar space. They're traveling through the local interstellar cloud. They're sending back data about the interstellar medium. They are revealing what the solar system is moving through. Voyager 1 crossed the heliopause in 2012. Voyager 2 crossed it in 2018. They are now in interstellar space, sending back data that we've never had before. They are measuring the density of the interstellar medium. They are measuring the magnetic fields. They are measuring the cosmic rays. They are our first direct explorers of the space between the stars. What have they found? The interstellar medium is not uniform. It has turbulence. It has structures. It has magnetic fields. It's a dynamic, chaotic environment. It's not the empty void we once imagined. The local bubble, a cosmic cavity. But the local interstellar cloud is not the whole story. We're not just in a cloud. We're in a bubble, a giant bubble of hot, diffuse gas. It's called the local bubble, and it's about 1,000 light years across. The local bubble is a cavity in the interstellar medium. It's a region of space where the gas is tenuous and hot. It's filled with million-degree plasma. It's the remnant of ancient supernova explosions. About 10 to 20 supernova exploded in the region over the last 10 to 20 million years. They heated the gas. They blew out the material. They created a bubble of hot, diffuse plasma. We live inside this bubble. Our solar system has been moving through the local bubble for about 5 million years, and will be inside it for millions of years to come. The local bubble is not empty. It's filled with plasma. It's filled with cosmic rays. It's filled with magnetic fields. It's a dynamic environment. It's constantly evolving, and we're moving through it. The solar system's movement through the local bubble shapes the heliosphere. The density of the plasma changes. The pressure on the heliosphere changes. The shape of the heliosphere changes. It's a delicate dance between the sun and the galaxy. The local bubble is part of a larger network of bubbles. The interstellar medium is not uniform. It's filled with structures, clouds, bubbles, filaments. The galaxy is a complex ecosystem, and we're moving through it. Think about the scale of this. The local bubble is 1,000 light years across. That's 10 trillion kilometers. It's so vast that our entire solar system is just a tiny speck inside, and yet it's just one bubble among many. The galaxy is filled with them. They are like the foam on a cosmic ocean. The galactic orbit, our path through the Milky Way. Now let's zoom out even further. Let's look at the motion of the solar system through the galaxy. The sun is not just sitting in one place. It's orbiting the center of the Milky Way. It's part of a massive gravitational dance. The sun orbits the galactic center, at about 828,000 kilometers per hour. That's about 230 kilometers every second. It takes about 225 to 250 million years for the Sun to complete one orbit. That's a galactic year, a cosmic cycle that predates the dinosaur. The Sun's orbit is not a perfect circle, it's an ellipse. The orbit takes the Sun closer to the galactic center, and then farther away. The Sun moves above and below the galactic plane. It oscillates like a pendulum. It's a gentle, slow, cosmic wobble. The Sun's orbit is influenced by the mass of the galaxy. The Milky Way contains about 100 billion stars, but most of the mass is not in stars. It's in dark matter, a mysterious, invisible substance that we can't see but we can measure. Dark matter dominates the galaxy. It shapes the orbit of the Sun. It holds the galaxy together. The Sun's motion through the galaxy is not just about speed, it's about direction. It's about the spiral arms of the galaxy. The Milky Way is a spiral galaxy. It has 4 major spiral arms. The Sun orbits between the arms. It avoids the dense regions. It avoids the regions where stars are born. It's in the suburbs of the galaxy. The spiral arms are not just decorative. They are regions of higher density. They are regions where star formation occurs. They are regions where supernova explode. The Sun's orbit takes it through the spiral arms every 50 million years or so. When it passes through a spiral arm, it experiences more cosmic rays, more radiation, more interaction with the interstellar medium. It might even affect the Earth's climate. There's a theory that the Sun's passage through spiral arms might have triggered mass extinction. When the Sun enters a spiral arm, the density of the interstellar medium increases. The heliosphere shrinks. More cosmic rays reach the Earth. These cosmic rays can cause mutation. They can damage DNA. They might have contributed to the extinction events that punctuate the fossil record. It's a controversial theory. Not everyone accepts it, but it's a fascinating idea. The motion of the solar system through the galaxy might have influenced the history of life on Earth. The motion of the Milky Way, our galactic journey. But the Sun isn't just orbiting the galaxy. The galaxy itself is moving. The entire Milky Way is hurtling through intergalactic space at about 2.1 million kilometers per hour. That's about 600 kilometers every second. The Milky Way is moving toward a massive galaxy cluster called the Virgo cluster. The Virgo cluster is about 54 million light years away. It contains about 1,000 to 2,000 galaxies. It's a massive concentration of mass. It's pulling our galaxy toward it. But the Milky Way is not alone. It's part of a group of galaxies, the Local Group. It contains about 80 galaxies. The Andromeda Galaxy, the Triangulum Galaxy, the Magellanic Clouds, and us. The Local Group is moving toward the Virgo cluster, but we're not just moving toward it. We're moving in a specific direction. The Milky Way is moving toward a region of the sky called the Great Attractor. The Great Attractor is a mysterious concentration of mass, about 200 million light years away. It's pulling on our galaxy. It's pulling on everything around it. It's one of the largest structures in the universe. But the Great Attractor is not the end of the story. The Milky Way is also moving toward an even larger structure. It's called the Shapley Supercluster. It's a massive cluster of galaxies, about 600 million light years away. It's the largest structure in the observable universe, and it's pulling on everything. So where are we going? We're moving toward the Shapley Supercluster. We're moving toward the Great Attractor. We're moving toward the Virgo cluster. We're moving through the universe, and we have no idea what's waiting for us. The cosmic microwave background, our reference frame. But there's another way to measure our motion, not just through the galaxy, not just through intergalactic space, but through the universe itself, using the cosmic microwave background, radiation. The cosmic microwave background is the afterglow of the Big Bang. It's a faint glow of radiation that fills the entire universe. It was emitted about 380,000 years after the Big Bang. It's been traveling through space for 13.8 billion years. It's a snapshot of the universe in its infancy. The cosmic microwave background is not uniform. It has tiny variations in temperature, but it also has a dipole, a direction. One side of the sky is slightly hotter, The other side is slightly colder. This is caused by our motion. The solar system, the Milky Way, and the local group are all moving through the universe, and this motion causes a Doppler shift in the cosmic microwave background. We're moving at about 600 kilometers per second relative to the cosmic microwave background. That's the cosmic reference frame, the universe itself. It's the speed at which we're moving through the fabric of space. But what are we moving toward? We're moving toward a direction in the sky called the CMB dipole direction. It's about 600 kilometers per second toward the constellation Hydra. But that's not the whole story. The cosmic microwave background dipole is a composite of our motion. It includes the Earth's orbit, the Sun's orbit, the Milky Way's motion, and the local group's motion. It's a measure of our velocity through the universe. Dark flow, the controversial current. Now let's go even deeper. Let's talk about something truly mysterious. Something that challenges our understanding of the universe. Some astronomers have proposed the existence of something called dark flow. It's the idea that the universe is not just expanding, it's also flowing, moving in a specific direction. A direction that can't be explained by known structures. A direction that seems to point beyond the observable universe. The evidence for dark flow comes from the motion of galaxy clusters. When astronomers analyzed the motion of these clusters, they found a pattern. The clusters were not just moving due to gravity from nearby structures. They were moving in a specific direction. A direction that couldn't be explained by the Virgo cluster, or the Great Attractor, or the Shapley supercluster. This pattern suggested that there might be something beyond the observable universe, something pulling on everything, something massive, something we can't see. The dark flow was measured at about 600 kilometers per second. It was in the direction of the constellation Centaurus. But here's the important thing. The evidence for dark flow remains debated. Some astronomers question whether the measurements were accurate. Others question whether the effect is real. Still others argue that it's a statistical artifact, a fluke in the data. However, other analyses have supported the dark flow interpretation. More recent studies have found similar patterns in the motion of galaxy clusters. The debate continues. The evidence is not yet conclusive. It's a frontier of cosmology, a place where we're still exploring, a place where we're still learning. If dark flow is real, it might be caused by structures beyond the observable universe. It might be caused by quantum fluctuation from the early universe. It might be an artifact of our measurements. We don't know, and that's what makes it so exciting. It's a frontier, a boundary of our knowledge, the interstellar medium and light. Now let's think about what this all means. What does it mean to be moving through the interstellar medium? What does it mean to be living in a bubble of plasma? What does it mean to be orbiting the galaxy? What does it mean to be moving through the universe? It means we're not static. We're not fixed. We're not standing still. We're part of a dynamic, ever-changing cosmos. We're moving through space. We're moving through time. We're moving through the universe. The interstellar medium is not just a curiosity, it's essential for life. The sun's motion through the interstellar medium shapes the heliosphere. The heliosphere protects us from cosmic rays. Cosmic rays can damage DNA. They can cause mutations. They can affect climate. The interstellar medium is a factor in the habitability of Earth. When the sun passes through a dense cloud, the heliosphere shrinks. The solar wind can't push back as effectively. The Earth is exposed to more interstellar material, more cosmic rays, more radiation. This might have affected the Earth's climate. It might have affected the evolution of life. The interstellar medium is not just a passive environment. It's an active force. It's shaping the solar system. It's shaping life on Earth. It's shaping the universe. Think about the cosmic rays. They're constantly streaming through us. They're causing mutations in our DNA. They are shaping the course of evolution. We are not separate from the universe. We are part of it. Every second, billions of cosmic rays pass through your body. They are a reminder that you are connected to the cosmos. The future. Where are we going? So where are we going? What does the future hold for our journey through the cosmos? In about 20,000 years, we'll leave the local interstellar cloud. We'll enter a different region of the local bubble. We'll pass through a different part of the interstellar medium. The heliosphere will change. The cosmic ray flux will change. The Earth's climate might change. In about 50 million years, we'll pass through a spiral arm. The density of the interstellar medium will increase. The cosmic ray flux will increase. The star formation rate will increase. The supernova rate will increase. The Earth's environment will change. In about 225 million years, we'll complete one galactic orbit. A galactic year, a cosmic cycle, will return to where we started. But nothing will be the same. The galaxy will have changed. The stars will have moved. The universe will have evolved. In about 4 billion years, the Milky Way will collide with the Andromeda galaxy. The two galaxies will merge. They'll form a new galaxy. The solar system will be flung into a new orbit. The interstellar medium will be stirred up. The universe will be different. And in about 100 trillion years, the last star will burn out. The last black hole will evaporate. The universe will become a cold, dark void. There will be no interstellar medium, no stars, no planets, no life. But that's not the end. The universe will continue to expand. It will continue to evolve. It will continue to move. It's a journey that will never end. The grand perspective. So let's return to the question we started with. What is the solar system moving through right now? The answer is a complex, layered, and beautiful one. We're moving through the local interstellar cloud, a warm, tenuous cloud of gas and dust. We're moving through the local bubble, a region of hot, diffuse plasma. We're moving through the galaxy, orbiting the center of the Milky Way. We're moving through intergalactic space, toward the Virgo cluster, the Great Attractor, and the Shapley supercluster. We're moving through the universe, pushed by dark flow, pulled by gravity, moving at 600 kilometers per second relative to the cosmic microwave background. We're moving through a dynamic, ever-changing cosmos, a cosmos that is full of mystery, a cosmos that is full of wonder, a cosmos that we're only beginning to understand. The journey of our solar system through the cosmos is a story that spans billions of years. It's a story that connects us to the stars, to the galaxy, to the universe itself. It's a story that reminds us of our place in the cosmos. We are not standing still. We are not fixed. We are part of a grand, cosmic journey. A journey that has been going on for 13.8 billion years. A journey that will continue for trillions of years to come. The next time you look up at the night sky, remember this. You are moving through it, not just looking at it, not just observing it. You are part of it. You are part of the cosmic dance. You are part of the interstellar medium. You are part of the galaxy. You are part of the universe. And you are moving through it all. It's one of the most humbling and beautiful truths in all of existence. We are travelers in the cosmos. We are explorers of the unknown. We are part of something vast, ancient, and extraordinary. We are part of the universe, and we are moving through it right now, at this very moment, faster than you can possibly imagine. The cosmic perspective. Every atom in your body was forged in the heart of a star. Every molecule you breathe was once part of the interstellar medium. Every cell in your body was shaped by the radiation that bombarded our planet. As we move through the galaxy, you are not just made of star stuff. You are made of the stuff of the interstellar medium. You are made of the stuff of the cosmos, and you are moving through it right now. The solar system's journey through the interstellar medium is not just a scientific curiosity. It's a fundamental part of who we are. It's part of our story, part of our place in the universe. The universe is not a static place. It's not a fixed stage. It's a dynamic, ever-changing, living system, and we are part of it. We are part of the cosmic flow, part of the interstellar medium, part of the galactic dance, part of the universal expansion. So when you look up at the night sky, remember this. You are not just looking at the universe. You are moving through it. And that movement, that journey, that incredible cosmic voyage is the most extraordinary thing you'll ever experience. A final reflection. We are travelers. We are explorers. We are part of something vast, ancient, and extraordinary. The solar system is moving through the local interstellar cloud, a warm, tenuous cloud of gas and dust. It's moving through the local bubble, a region of hot, diffuse plasma. It's orbiting the center of the Milky Way, completing a galactic year. every 250 million years. It's hurtling through intergalactic space toward the Virgo cluster, the Great Attractor, and the Shapley supercluster. It's moving through the universe, pushed by dark flow, pulled by gravity, traveling at 600 kilometers per second relative to the cosmic microwave background. We are moving through a dynamic, ever-changing cosmos, a cosmos that is full of mystery, a cosmos that is full of wonder, a cosmos that we're only beginning to understand. The journey continues. The universe keeps moving, and so do we. So the next time you look up at the night sky, remember this: you are moving through it, and that is the most extraordinary thing of all.